This is an example of a quadratic function which has been presented in vertex form. Vertex form is pretty easy to work with because you can get a lot of information and graph it almost directly from the equation without doing a whole lot of calculation. When in vertex form, there are several transformations that we can pick out right away. The first is the coefficient A, and this A tells you whether or not you're going to flip, whether or not you're going to compress or stretch your graph. The second piece of information that we can get, the second kind of transformation, is whether or not we're going to shift left or right. Remember that our parent function is going to be centered over the 0.00, so h is going to tell us which way our x-coordinate is going to move. That is our left, right shift. And finally, k is going to tell us whether or not we're going to move up or down from that 0 point. So that is our vertical shift. And as always, we need to identify our parent graph. We know it's a quadratic function, and we can identify that from our power of 2. So our basic parent graph is going to be our x squared graph, and that is the parabola that's centered around the 0.00. Let's move over and look at our example here, and let's see if we can identify all the transformations and then graph it. So first of all, we look at our coefficient A, which is a -2. The negative tells us that we will be flipping our parabola. So it is going to flip across the x-axis, which means it's now going to be upside down. And that 2 tells us that we're going to stretch by a factor of 2. So our parabola will actually get narrower. It's sort of like a rubber band. When you stretch a rubber band, it gets narrower. So we're going to stretch. Now we look for h, and h, remember, is the opposite sign here. So h is actually a -2, which means we're going to shift our 0 point to the left by 2 units. And finally, k is a -3, which means we're going to go down by 3 units. So let's go over to our graph and let's go ahead and plot our new center point. So we're going to go left from 0 and then down 3, and so our new center point is right down there. And now our graph, we know, because we're stretching it, it's going to be narrower than our normal parabola would be, and it's upside down. So we've got something like this. Now that's just a quick sketch. If you really need an accurate picture of your graph, you need to go find some more points to see just exactly how wide that thing is. But for our purposes, we're going to leave it as is. Let's look at the other information that we can get from the function itself or from the graph. First is the domain. Remember, the domain is a set of all the inputs, all the x values that are legal, and by that we mean any value you can put there which will not blow up that function. So with quadratics, you can put in anything that you want. That's supposed to be a rounded parentheses there. So our domain is from -infinity to infinity. Our range is all the possible outputs. So if you look at the graph, that would be all the possible y values. And we see that we don't have any part of that graph that goes above the -3. So -3 has got to be our highest value, and we go down from there. So we go down forever, -infinity. The vertex is the center point of the parabola, and we know we can find that from h and k, and we can see that on the graph. Our vertex is the point -2, -3. And finally, the axis of symmetry, which, recall, is the point that draws a vertical line through your center point of the parabola, and I will draw a dashed line here to indicate that. So if you had a piece of graph paper and you plotted this graph and then you folded it in half along that red dotted line, you would see that the two sides of those parabola were exactly one right on top of the other. So the axis of symmetry is always a vertical line that goes to the center point. So for this particular example, x is equal to -2. And that's it.